Today we will produce such a salt cellar holder out of Miranti wood on this entry price segment router, which is a type 3018-MX3 of the company SainSmart. This router is to be controlled by the dedicated CNC control software. For this we will use the DrufelCNC software, which comes at a relatively low price, also for very big files. So cheaper than the industry standard Mark III software, which is quite expensive for household application. We will cut the wood, such a piece of Miranti here. We will cut this with a straight flute cutter of 1/8 of an inch, so 3.175 millimeter. That is then also the lowest radius which we can have here at the inner corners of our piece. Any kind of other formats and wood formats can also be produced. And to actually produce all this, we of course need CAM files. And the CAM files we will first of all generate, so construct the thing in a 2D CAD system, which is easier to use than all the famous 3D CAD systems. We will use QCad. QCad is a free open source CAD software. And out of this CAD drawing we have to produce then CAM files. The CAM files we will produce with QCAM, which comes at a relatively low price. So the target is then that we show all the different settings that are necessary for such a production. So which settings we have to use within the QCAD and QCAM to be able to produce a file that then can be loaded into the DrufelCNC software, the settings within the DrufelCNC software which have to be set for this router device, and then finally also the execution of the same thing, so that we see how this gets really built up. So if you're interested in these topics, stay with me and I hope you can enjoy. First thing we have to do is take our measurements. So two of these salt cellars together have a width of around 52 millimeters. So we go for around 53 as an inside dimension of our final box. I started QCAD already, and the first thing is we create a new drawing. Within this new drawing I normally switch off these grids, check that we use millimeter and metric system here for what we are going to do, and that we set this G-code setting here to G-code offset millimeter. So only with this setting we are able to generate valid files for the execution in DrufelCNC. And if you change this after the point in time where you have constructed your first toolpath, then you have to repeat generating and setting all toolpaths after this again. Especially for the toolpath setting at entry points, this is also crucial. The behavior of the CAM module within the QCAD is different based on this G41, G42 part here, which you see. So this one, or in this in millimeter, and the offset one. So please make sure you don't forget to set this setting. Okay, so next thing that we do is we create two layers. First of all, a base layer in which we will put all the things that we draw, what in the end will be visible to at the final piece that we keep in our hands, and we will enter also a dimensions layer in red here, and we make sure we draw to the base layer by selecting this line. First construction is now to have a line of length 53 millimeter, which we will start here at the starting point of the 0 point. You see at the moment it doesn't snap, so we switch on here this snap to grid mechanism, and we have our very first point set. Can press escape to get out of this, and we select now a vertical line with the same length of 53 millimeter. And for this, you see there is nothing special selected any longer, and by this QCAD now snaps to the ends of this line, which is very crucial that you see this word end here before you give a click, and then you are sure these lines really match together. So we construct these two vertical lines, go back another horizontal line, and we are done with the inner of our salt cellar holder. So now we want the outer we want to draw the outer dimension now. For this we use the align parallel mechanism, and we want this in a distance of say 4 millimeters. So we have selected this, given our distance here, and we hover to near to this line, and you see it is now, if we click, drawing a line to the outside. If we hover to the other side, the parallel moves to the other side. So, and you also see that the line it is drawing a parallel line to gets a little bit darker. So we click here, 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 and here, and have our parallel lines. Now we want to zoom to all to see everything centered in the middle, and press escape till this here all cleans up and we come to the main menu again. So now we want to have roundovers here, or if you want to have sharp corners, you can set for both. If you go here and use this trim, so trimming both, can have by selecting these two sharp corners. So you would click here and you get sharp corners, but for the moment we want round corners. The question is what kind of rounding we want, and that comes actually from our router size. So the router later will move up here till this point and then make its way and leave a round corner here with a radius of half of the dimension of our router. So let's see what this means. Again, I draw a parallel line, and this parallel line is now 3.175 millimeter, or divided by 2, which I can put here, and I construct two lines which help me to find the center of this. So the router will end up here. Can also depict this by drawing a circle here with a radius 3.175 divided by 2. So this will be the roundover in our inner corner in the end. So, and what we want is now that we have a rounding that goes like this. So the next thing that we do is we measure this distance, come to this by this menu, and we draw now this kind of distance marker here, so horizontal distances, and we see that from this point, from this line, the distance to here is 5.5875 millimeters, which is our 4 plus half of the diameter of the router bit. So now we change back to our base and we give a round over to our corners. So we type in a radius of 5.58, select this outer two white lines and get the round over, and do the same also on the other sides. Then you also see you don't even have to trim any longer before, and that's it. Can zoom all and make the dimensions layer invisible, and here we have the outer base of what we need. We want one toolpath that runs around all this corner, and for this we start to build our CAM setup. So we start first of all with CAM configuration and set the output file. That is the directory, and it offers us to name this in the way as we have our original file, our DXF file, how it is called, and that is okay for us. You can optionally give a number for this if you need different tools later on. That can be handy, so I name it 1. And there is a security layer here, so the height at which the cutter head shall end up to do a change of cutters and at the end, and we choose this to be relatively near to the top of our surface. Around 2 mm are definitely sufficient, since our SainSmart router has only a very limited height in the Z-axis. It does not make sense to take very big values here. So all the other settings I keep here the same, but the G1 I want this to be written all the times. So this is the setting that I use here. To create now the first toolpath, first of all we have to define a tool itself. So we have this menu here outside, and there is the tool list and the so-called tool path list. So the first thing we do is we define now our tool. So the tool is a straight cutter head of 3.175 mm dimension. For the spindle speed we use some value of, let's say, 20,000, which in the end does not make a big difference. I couldn't see any effect of this really in that in DrufelCNC. Anyway, 20,000 rounds per minute is not reached by the spindle of the SainSmart router. So for the linear speed we take now a value of 300, and for the movement in Z direction of 100. These values come from experience for the for the material which you work on. So these were settings which worked with my Meranti wood. So by defining this, we have now this tool defined. Now we have to create the first tool path, and there is something we have to know about the selection mechanism in QCAD now. If you click on one of these pieces and then click right, we get a different menu context here. Then if we have no selection and do a right click on this. So that's what you want to do now. You want to only right click on this and to select the complete contour here. So all these things get selected. And the next thing is now we create one object out of this. And that is what we do by create a polyline. And this now leads to the effect that we have one object now, one complete set of lines here. And for this line we will create now a toolpath. So we can now after we define this polyline, create a tool path. For the tool path, automatically the router which we created, tool which we created, is selected here with its values, which is good. So this is again the security layer, the height of the tool at the starting point, and the cut start area is at 0 mm, that is the top, and we want to cut down to 15 millimeters, and we want to do this in, say, around 9 cuts. Also this value comes from experience. So that is what you have to try out. So depends on the quality of the cutter heads which you use, on the spindle speed, on the material which you have, but these values were okay for me. Maybe we could even use here an 8 for 15 millimeters, but okay, we go with this 9 for the moment. We want to cut on the outside, and we want to cut in the direction away from the material. So that's good. And especially for this, we don't want any approaching tool path or a path to go away, because if you have to select this, and remember this G-code offset setting here, this G-code offset allows you to have no tool pathway here. If you come with this G41, G42 stuff, the QCAM behaves in such a way that it forces you to have one of these, and by this on some materials and in some situations you cannot create a valid toolpath without cutting into the pieces that should not be touched, so into the things which you want to keep. So it was very crucial actually to select this G-code offset, also due to this behavior of QCAM. So I don't want this here, it should be really set to no, and that only works with G-code offset. So now the system works, you see it is running here and calculating, and after some seconds we see our first tool path, which is okay. The construction of the outer tool path was relatively simple, and for the inner tool path we have to do some more considerations now. So the first thing what we do is also here we create a polyline out of this, so we have one object and we want to hollow this out. The tool passes are constructed alongside a path, as we know, and we need now passes inside this complete area. So, and that is what we usually get if we add a hatching to something like this, where we can select a pattern and fill the area. And if we would do it like this, that would hollow it out, but we run into a big problem now. The problem is that here at this point, if you remember, actually our router, at the beginning when we constructed, we saw that the router goes this way. If we would now create a tool line that follows this hatching line, it would definitely cut till here, and the router bit would cut into the piece of material which we want to keep. So we have to do the hatching with an offset that is somehow 3/4 of the dimension, the outer dimension of our cutter head. So I revert back this last change now and get rid of this hatching again, and first of all we will construct some offsetted lines in a new layer which I call remove. Select this for drawing. Have line parallels with 3/4 of the outside dimension of our router bit. So somehow like this. Parallel lines as shown before. Now we trim them with this TM module to not touch anything on the outer. And now we have an inside dimension. Select this, create a polyline of it, and we fill it also again with the hatching. So now what will happen now is, if we look again at the corner here, if a router has its center here, it will not touch the outer line here, and we can construct two lines or tool passes along the hatching completely. And after we have constructed or done this cutting out of the hatching and the inner contour here of this contour, then we will still have a small piece of wood left here, which we can cut out then in a final tool pass, leading to a clean edge. Before we can start to construct the tool pass, we have to do one more consideration, and that is on the distance of the lines here. We did not control this at all. We simply said there is a scaling of this of 1. We have to somehow find out what is the distance here, because if a cutter runs here along this line and also here, the distance between the lines should not be bigger than the diameter of our cutter head. So what we do now is we measure this distance between the two lines. Get this here, so we have to get this dimensions visible, and what we see is that that we got exactly the diameter of our cutter head. So then we have no overlap at all. That is not too good. So what we do now is we edit the hatching and say the scaling is 0.9. So it's get rid of this again and redo our measurement from here to here. Now it's 2.857 millimeter. That is okay because it's a little bit smaller than our 3.175 of our cutter. Okay, so we move this again and we check that our hatching is useful now. Next step is now to construct tool passes, and what we want to do is actually to first of all hollow out the area. So we can select the hatching, say we add a tool pass, we keep our setting for the tool itself, starting point is okay, 0 is our starting point. We want to cut down to 10 millimeters. We do this in say 7 cuts, or 7 cuts, and we'll do this on the lines of the hatching without anything here, so that's okay. This will be calculated now. That is profile 2 now. Once we have done this, we select the outer area here, add another profile. We again run on the line. We want to cut down to 10 millimeter in 7 cuts, and we do this in the opposite direction away from the workpiece. Now that's then the next thing. And finally the real last cut, where we want to have a good result which is visible later. We again go down to 10 millimeters in 7 passes, and this we finally do on the inside in the opposite direction. So that is then the last cut. So now the profile 1 was the one on the outside of everything. I will move this down to be the very last cut which we do. So we start with hollowing out the most of the material, then doing this cut once around, then doing the final passes on the inside, and finally the outside of everything. To check the result of what we have done, we look now at the CAM simulation of our toolpath. Can control here the speed, and we should not set this too high, and here we can move around the different steps. And if we start this now, we see that the router bit will move here alongside along the tool passes for the hatching. They will go 7 times for each line, so that looks okay. And we also have a look at how far it goes to the side, how near it comes to our line here of our good or kept material, and that looks all very much okay. So I can move this now to the front to check the end here. Also that is fine. And after it has done this all 7 times, it moves now on the inner contour here, and you see here this cut will be then really into the material. On the others, most material will have already been removed, and it flattens then all these shapes which we have here at the ends of our tool passes. So also this takes some time, run 7 times around, then we'll do the inner final cut, and that also looks nice. On the inside corners, no overshoot shown, everything okay. Then we have to wait to see the very end on the outside. Move there and goes on the outside, so that all looks nice, and more or less we are done with what we can see here. QCAM also offers you a 3D view of the tool passes, but I did not find this too useful for my purpose, so we won't go into this. Has a very similar approach to this two-dimensional visualization. Final step is now in the CAM system to export the file. That is done by pressing this button, and now all these tool passes are recalculated before it finally writes the file. After saving the file, got it here in our directory, and we can go and fire up DrufelCNC. we simply drag and drop the file here and see already that the file is also visualized here. That all looks good, and we can now go through the settings for which are required actually for our SainSmart router. So we have access settings here to be done, and well, these are all straightforward. If you need the settings, pause the video and check it. These are figured out from different videos and will control our router. So here is the spindle speed. Since we have given 20,000 rounds per minute, that will then end up in the highest possible speed in the end. The first thing on the router is to set the 0 position of the Z-axis. So I have my workpiece, which is 20 millimeters thick, tied to the bed, and I have the 14 millimeter height probe on the bed. So the effective height of the probe in this setup is -6 millimeter, which is the 20 minus the 40. And I will run the find program for this -6 millimeter here till the 0 position is found. And after I've done this, the next step is now to put this away and to go manually to the starting position of our cut. So this should be fine like this, and here I zeroed my X and Y axis, and now from setting point of view I'm ready to go. What is missing is the dust extraction. So, and there is not more to do than this, and now to start the execution, and that will run for around 55 minutes. I doubt that I will be able to capture all what is going on, but we see what happens. So, cutting is finished, and we see that we have a small breakout here in this area. We have to see what we do with this. Maybe we have to cut it down, or maybe we simply have to repeat the complete process. But what is obvious is that all that we constructed within the QCAD system turned out to be right. We did not produce a problem from what we cut it and how we arranged it. So overall the result is quite as planned and as expected. Okay, so oiled and more or less finished up. We have produced our piece, and yeah, to summarize, if the wood would not have been broken here, the piece would have been totally okay. Like this, I don't like it in the end and will not be the one which I put on my table in my living room. But technique wise, everything went out fine and as is expected, so the roundings, the roundovers are okay, nothing special. A little bit of cleanup was required. I didn't do it now to the complete extent as if I would have done it if this was not broken. But of course, if you build something like this, you can consider to make the sides a little bit wider. Then this does not happen so easily, and so this breaks in the end very easily. And I will put this now into the scrap bin, but technique wise that should be fine, and hope you enjoyed and it was useful for you to see how to do the settings for the SainSmart router in QCad and QCAM and how to use then the DrufelCNC. One more point for information, so this was still the free version of DrufelCNC for such small project that still works. It is there is no limitation with respect to the size of this one, so quite useful, and maybe you consider this, and maybe you also consider subscribing to the channel. So thank you and have fun. Let me know if you have questions.